Now let's see how does the array division will work. This is the division operation. It is also associated with the rules of linear algebra. So we have two kinds of divisions available for arrays. The first one is left division and the second one is right division. So this basically uh, multiplication of inverse, which we want to be used as a one of the matrix with a matrix B. So let's see. Okay, so let's start with the division. The division operation is also associated with the rules of linear algebra. Now we have two kinds of divisions available for the arrays. The first one is left division and second one we have right division. So what is difference between left and right? So let's say we have a left division. It is used to solve the matrix equation Ax is equal to B. So where A is the square matrix, let's say, and X and B are the column vectors. Okay, so this equation can be solved by multiplying on the left on both sides by inverse of A. So this is the equation. If you multiply inverse of A on the both sides, this will be the equation, final equation. So A inverse into A into X is equal to A inverse into B. Now this A inverse into A is nothing but the identity matrix. So this will become I into X and ultimately it is X. So X is nothing but A inverse into B. So this will be the solution of the matrix or linear equation Ax is equal to B. So in MATLAB we will write this X is equal to A left division B. Okay, so let's move to the right division. The right division is used to solve the matrix equation X into C is equal to D. So what is X into C is equal to D? In earlier equation, A into X is equal to B was there and X and B were the column vectors. Now here we have this X and D as a column vectors and C is the let's say square vector. Okay, square matrix. Now in this equation X and D are the column vectors as I said. So this equation can be solved by multiplying on the left both sides by now this will become on the right both sides by inverse of C. So we are multiplying on the right side C inverse and on the right side C inverse. So please forget about this thing. So this is on a right both the sides by the inverse of C. Okay, now so the solution of X into C is equal to D is X is equal to D into C inverse. So in MATLAB we write this as a X is equal to D into or D right division by C. Okay, so we'll see this in the MATLAB. Okay, so let's move to the left division first. Now we have this set of linear equations. Let's say 4x minus 2y plus 6z is equal to 8, 2x plus 8y plus 2z is equal to 4 and 6x plus 10y plus 3z is equal to 0. Okay, then we can write this thing in the form of A is equal to and B is equal to. Okay, so this will become A and B. Now we run this thing, then we have this X is equal to inverse of A star B. Okay, so this is the actual solution. We'll run this program here and this was the A, B and we got the answer using the solution that is inverse of A into B. Now we'll perform the left division on A and B and we'll calculate the x1 and we'll compare x with x1. So this is the x which is we got by inverse of A into B and this is x1. This is A left division B. So both the values are same. So this is nothing but the left division. So we can solve this for a right division also. Okay, So we'll consider a system of linear equation. Let's say we want c or x into c is equal to d. Okay, so we'll constitute a c is equal to, we'll take few elements. Now we will copy these elements from a previous multiplication example. Okay, so this will become a c. Okay, and we have a d is equal to, we'll copy this thing from here and d. Okay, now what we want a right division, so we calculate x2, we'll calculate x2 is equal to, now d star inverse of c. Okay, and then we will calculate x3 is equal to d right division c. Okay, I will check this thing. So what's the problem? Incorrect dimension matrix multiplication. Oh, so d we have to use this thing, and else here also we have, so d by c, that's correct. Okay, so this d must be a row vector if we want to perform the right division. I was unaware of that thing, and now you can see, so the values are same. Okay, so let's go to the element by element operations. Okay, now up to this we have seen the multiplication by the rules of linear algebra. Then if in certain terms we have to calculate uh, element by element multiplication, let's say we have array 1, we take element by element multiplication is equal to, now we'll do it for ARR C star ARR B. Okay, now we will be doing it with A and B. First of all, we will multiply, just multiply ARC into ARB. Okay, so ARB is not there. Okay, so this is the multiplication. Now we'll do element by element multiplication of ARC, is array C and array B. You just have to use dot before the star or the asterisk marks, and we'll do this thing. So you can see here, this is the multiplication if you do a normal multiplication, and this is the element by element multiplication. Okay, so you can see the difference if you'll see the elements. Okay, now we want ARR underscore C as well as ARR underscore B here only. Now okay, so C is here, B is here, so 6 into minus 6 will become minus 36. So this is how element by element multiplication works. So 2 into minus 2 will become minus 4, 9 into minus 5 will become minus 45, and if you see the normal multiplication, the elements are completely different. So this is how the element by element multiplication works. Then we can perform element by element exponentiation also. So we'll do it with array C. That's fine, array C. So first of all, we'll do a square of array C, normal exponentiation. Okay, so what we want power of a array is equal to AR underscore C, and we'll do it square. Okay, and element by element power, you can see element by element underscore power of array. Okay, then we will do it for same array C. By this time we will just add a dot before power. I can see here this is the square of AR underscore C, and if we do element by element exponentiation, we get this element. So this is how you can do element by element exponentiation. You can perform the right division and left division also. Now okay, so we'll just click here and take here. We'll just do a right division first for this multiplication division, so GST. Okay, and again a left division as well. Okay, so we'll see these two results. Okay, so you can see here a right division and a left division. The few of the elements are same because might be this two elements of these two vectors or matrices will be same, but you can see here the row 1 column 3, the element or this element is changed, this element is changed, this element is changed. Okay, this element is changed, this might be 1 by this might be 1 by 3, and this is 3 by 1 minus 3 by 1. Okay, so this is how element by element operations will work. Okay, now we have some built-in functions for analyzing the arrays. Okay, so what array we'll choose array D. Okay, so AR underscore D, and we'll run this thing first. Okay, so this is the array D. Okay, now we have to find out the mean of this value. So let's say array mean. Okay, mean, and we want it for is equal to mean and AR underscore D. Okay, now if we'll perform this thing, you can see here this is how you can find out the mean of the columns. Okay, so 616, we'll add this thing and take an average, these things and take an average, so we'll get the mean. So this is mean. Okay, now we want to perform maximum. We have to find out the maximum element. Okay, so we have okay, we'll do this thing first. Array max is equal to max, this is the function, already. Okay, now these are the maximum elements from the rows. Okay, now we perform like this: D comma n and is equal to max of run this thing. So you can see here it is also giving the number. So this element is the first element in this row, this is the second element in this row, and this is the third element in this row. So you can get the numbers of the element numbers from the rows from this matrices as well. Now we'll take help this max. Okay, so the max of a vector will get vector, it's okay. Now we'll get the row wise, or sorry, column wise. This is the 7, this is the 8, and this is the 9. Okay, largest element in each matrix row. So now if you want a maximum from A, and this is the 2.1.1.99, so this is 2. So create a matrix and compute the largest element in each row. That's column wise. Okay. So let's go to this. This is giving us a column wise 6, 1, 6, 6, and this is also okay. So this is moving column wise. If you want row wise, then we'll get like this. This is column. Now want a row wise, we have to this thing and 2 or all. Yes, that's it. So all is giving a single, and if we do it to, yeah, so the row wise, the first, in the first row we have maximum element as 9. In the first row, second row we have 6, and this third row we have 20. So this is the element number. Again we are getting the element number, and if you want maximum element from whole numbers or all the 9 elements, we have to use this all. Here, so this is matrix. So this is 20 and the element number is 9. So this is how you can use the max command to find out the maximum element, and it's, so this is the column wise operation, this is the row wise operation, and if you want to use the whole matrix, you can use this command. So the similar way we can work with the minimum command, min. So you just have to replace this with a mean, and mean. So it will work the same way the max is working. I'll add CLC here. Okay, so array mean, so this is giving a minimum, a column wise. You can see here minus 1 is the minimum element in the column first, 2 is the minimum element in the column second, and 3 is the minimum element in the column third, and these are the numbers. Now here this we have performed column wise. Now we have a row wise 2 minus 1 1 and the corresponding numbers, and from all we have this thing. So that's it for minimum. Then you can perform the sort operation. Okay, we'll just start with sort operation. Copy this thing, use sort. I'll add a CLC here to clear this. So it has sorted this thing along the column. So hope you remember that. Oh, we'll just print ARR underscore D. Okay. Okay. So this is ARRD, and we have this. We want sorted. Okay. So this is ARRD. This was the original matrix. We use the sort command. You can see here this element went to number 1 position and 6 and 6. 2 went to the first two and 6 went to last. This will become 1, 9 and 20. Now we'll test it with the same row and matrix. I don't think so it will work with the matrix. Still we'll give a try. So you can see here sort, it's not working with the dimension algorithm must be, so we have to take help how to do it with the row wise. Now we have the same help dimension. Okay, sort vector in ascending order, so sort matrix rows in ascending order. Yes. So sort a comma 2 we have to give it, and descending order, so you have to write this descent. Okay, then we perform this thing sort, and we just have to remove this thing. So we perform a row wise operation. I think so. We have to leave it once again. Okay, so DTT sorted. You got D and you got the numbers. So D is, now we sorted this 269 refer to the ARRD. So this 2 will move to the first place, 6 will be the second place, then minus 116, is it correct? Minus 116 and 2620, yes, that's correct. And these are the numbers. We don't want the numbers, we can remove directly. So let's D, and if we run this thing once again, the first time it will not work. So you can see we got a sorted row wise. So this is 12B R O W, and this is normal is column. CLC. So here is the ID. This is column wise sort, this is row wise sort. Now if you want descending order, again descending order, descent, yes, I want to use this thing. And can I use it here as well? Yes, I can use. Yeah. So this is descending. Give it once again. Yeah. So this is ARRD. This is sorted column wise. This is sorted row wise. This is sorted column descending order. This is sorted. This is sorted row descending order. So this is the sort operation. Then we have used this determine. So determinant. We perform a standard deviation first, STD CLC ARRD underscore D, that's array dt. Then we want to use standard deviation equal to STT, standard deviation of ARRD. Yeah, so this is ARRD, and we got the standard deviation row wise. Can we do, oh sorry, column wise? I think so this is column wise because the default is column. And can we do it row wise like this? No, this is not the way. Yeah, so let me see what is the help center. We have took a wrong help. We want sort standard deviation. So A and W, standard deviation of matrix columns, standard deviation of 3D array. You get the 3D array. No, we want weights. We don't want to along with the matrix. So this is the formula. This is the syntax A02. So array 02. So this is how we'll get it row wise and column wise. Okay, so this is a row. Okay, this is column. This is by default. It gives it a column and row. Okay, that's it. Then determinant of the vector is equal to that of A R score D. Is it working? Yeah, determinant is given directly. Now dot product, cross product. Dot product we have used already. Cross product of the vectors we have to do. So cross, we have the vectors is where vector multiplication. Yes, these are the vectors we have. We'll copy those. And we'll perform cross product is equal to vec A. Sorry, we just have to use this cross command. Then vec A comma vec C. Yes, and that's it. A must be of length 3 in the dimension, which is must be a cross product taken. Okay, so what is the this to be must be row vectors. Okay, so we'll be doing this like this. Is it possible? Or it is saying that it should be of 3 by 3. Yes, it should be of 3 by 3 because cross product works with IJK. Yeah, correct. So it works with IJK. Yeah, this is the cross product. So one ABC is there, and we have multiplied A and C. A and C 2. I don't know how does it work. You just carry out the mathematics. Okay, so inverse we have already done. So that's it from this building functions for analyzing the arrays. Okay, let's meet in the new video the next week.